Welcome to the video series for best MCQs in ICSE Physics. We also welcome you to our YouTube channel Physics Theories and Numericals, where we are providing you videos for easy and joyful understanding of physics theories and concepts for life. We have designed this best MCQ series with lot of care. We are providing you high quality MCQs. With each and every answer, we are giving you explanation so that you can refresh your concept and strengthen them. We are providing timer with the MCQs so that you can do your own calculation before we take you to the answer. Now this video is with very high learning versus time ratio. That is, you take a video of half an hour, it will be having 20 to 22 MCQs in that. So if you compare with some other normal class, you will find that here spending half an hour time, you will be learning much more. I request you to go through the entire video. I can assure you that you will get super MCQs in this video series. We have already uploaded high quality MCQs for your chapter 1, that is force, chapter 2 work, energy, power, chapter 3 machine. This refraction we will cover in 4 videos. 3 videos we have already uploaded, 4th video we are uploading today. We will provide you the link for these videos in the description box so that you can go through the videos immediately. This video is for your chapter 4D, that is total internal reflection in prism. The first MCQ. In the figures below, glass prisms with critical angle 42 degree are kept in air. An incident ray also has been shown. Now in which case the refracted ray will pass through the point P. You have about 15 seconds time for this MCQ. Your timer starts now. Time's up. Let's see the answer. The answer is option C. Now let's understand the ray diagram for each of the cases. The first case, you can see there are 2 internal reflections and the outgoing ray is no way close to the point P. Option B, here also again there are 2 internal reflections. Here also the outgoing ray is not close to point P. Third option, there will be only 1 internal reflection and you can see the outgoing ray will be going through the point P. So that is the option. Let's see the 4th option also. The 4th one, here you can see there is only 1 internal reflection, then the ray is coming out from the prism. But outgoing ray is not close to the point P. So your option is C. Next MCQ. For an equilateral prism, the critical angle with air is 42 degree. If the incident ray is perpendicular on the refracting surface, then what will happen? There are 4 options. The ray is refracted through the second surface. It is reflected from the second surface and emerges perpendicularly through the third surface. It gets reflected from the second surface and third surface and emerges through the first surface. 4th option, it keeps reflecting from all the 3 sides of the prism and never emerges out. You have got 10 seconds for this MCQ. Your timer starts now. Time's up. Let's see the answer. The answer is option B. That is, it is reflected from the second surface and emerges perpendicularly through the third surface. Let's see the ray diagram also. So here the angle of incidence on the second surface is more than critical angle. Here it is 42, but given critical angle is 42 degree. So it is more than critical angle. So the ray will get internally reflected on the second surface and it will come through the third surface perpendicularly. Next MCQ. If a glass prism of refractive index 1.5 is kept in air, the light ray entering perpendicularly through a refracting surface gets internally reflected on the second surface as shown in figure 1, and just as we just saw in the previous MCQ. That we know. This is what in figure 1. Now if the same prism is kept in a liquid, the same ray makes a grazing emergence along the second surface as shown in figure 2. That means when this same prism is put in liquid, the same ray creates critical angle. So you need to find out the refractive index of the liquid. 4 options given. You have got 10 seconds time. Your timer starts now. If you think you require time in between, do pause the video, take your time, come to the answer. Time's up. Let's see the answer. The answer is option C, that is 1.3. Let's understand the calculation also. You need to calculate refractive index. That means you need to find out angle of incidence and angle of refraction. Here it is critical angle, so angle of refraction you know it is 90 degree. You need to find out the angle of incidence. Look at the diagram. The top, the small triangle gives you the angle 30 degree the ray makes with the second refracting surface. So from that you can find out that angle of incidence, that is 60 degree. That is basically critical angle in this case. So critical angle C is 60 degree. Now here, who is rearer? Liquid is rearer medium, because critical angle is getting created when light is traveling from glass to liquid. So sin 60 will be 1 by mu. What is this mu? Mu is refractive index of glass relative to liquid. So that is sin 60 will be glass mu liquid. That means sin 60 is equal to refractive index of liquid by refractive index of glass. Do the calculation, cross multiplication. So you get refractive index of liquid is equal to 1.5 into root 3 by 2, that is 1.3. Next MCQ. A prism with critical angle 42 degree with air is inserted in a liquid of critical angle 49 degree with air. Now what will be the critical angle for the prism when it is inserted into the liquid? It will be less than 42 degree, it will be between 42 degree and 49 degree, more than 49 degree, cannot be determined. You have got 10 seconds time for this. Your timer starts now. Time's up. Let's see the answer. The answer is more than 49 degree. Let's understand also. See, the critical angles of the two mediums, one is 42 degree, another is 49 degree. They are very close. So that means their refractive indexes also will be very close. Once their refractive indexes are close, so their mutual refractive index will be very close to 1. So the critical angle will be more. In fact, critical angle from glass to air is 61 degree. Next MCQ. 4 rays marked P, Q, R and S are entering a 30, 60, 90 degree glass prism kept in air. The rays are entering at 90 degree with the surfaces. The critical angle between the glass and air is 42 degree. The 4 rays are shown here. You need to select which rays will suffer total internal reflection. You have got 10 seconds time. Timer starts now. Time's up. Let's see the answer. The answer is option B. That is, ray Q and R will have internal reflections on their way. Let's have a look at the ray diagrams also. See, the four rays are shown in four different colors. The first one, ray P, that is red color. So it is entering straight. Then on the hypotenuse surface, it is entering at an angle 30 degree. You do the geometry, that angle of incidence here is 30 degree, so no internal reflection. Green color ray Q. See, it is entering straight through the base, and on the hypotenuse surface, the angle of incidence is 60 degree. You do the geometry, you find out that star marked angle, green star marked angle is 60 degree. So it is more than critical angle, so there will be internal reflection. For R also, with the base, the angle created, that is star marked in black, that is 60 degree. So there will be internal reflection. But the blue color S, there will be no internal reflection. So there are four rays. So your option is Q and R. That is option B. Next one. For a 90-degree prism to be used in a periscope, identify the required condition for the refractive index mu. There are four options given. Now you calculate the required condition for the refractive index. You have got 10 seconds time. Your timer starts now. Time's up. Let's see the answer. The answer is option C, that is mu should be greater than root 2. Let's understand the calculation also. Look at the picture of the periscope. The rays are coming into the prism, and on the hypotenuse surface, the angle of incidence is 45 degree. In that angle of 45 degree, the ray has to do the internal reflection. That means that 45 degree has to be greater than the critical angle. So mu should be greater than 1 by sine 45, that is mu should be greater than root 2. Hope you are liking this video. Please subscribe to the channel, like, share and comment on the video and press the bell icon. Next MCQ. Three rays of different colors, yellow, green and blue, have entered a 90-degree prism kept in air as shown. The green ray, the middle one, the green ray grazes along the second refracting surface. That means it is creating critical angle. What will happen to the other two rays, the yellow and blue rays? Four options. They will follow the green ray. Option B, yellow ray will have refraction and move out in air. Blue ray will undergo total internal reflection. Option C, both of them will undergo total internal reflection. Option D, blue ray will have refraction and move out to the air. Yellow ray will undergo total internal reflection. You have got 10 seconds time. Timer starts now. Time's up. Let's see the answer. The answer is option B. That is, yellow ray will have refraction and move out to air, and blue ray will undergo total internal reflection. Now let's understand. These three color light, they have got three different refractive index. The refractive index for blue is more. In fact, all the rays are making same angle with the hypotenuse surface. Now, for the green color, that angle is critical angle. Now, as refractive index of yellow is less, so that angle will be less than the critical angle. So, yellow ray will have refraction, it will come out to air. But blue color the refractive index is more, that means critical angle will be less than 45 degree, so it will have total internal reflection. Next MCQ. A ray is entering 90, 60, 30 degree prism. Refractive index is √2, kept in air as shown. You need to find out the value of the angles I and arc marked in the diagram. 4 options. You have got 10 seconds. Your timer starts now. If you require time in between, please do pause the video, take your time and come to your answer. Time's up. Let's see the answer. The answer is option C. That is I is 60 degree and R is 45 degree. Let's see the explanation. Now, as I have been telling, that refraction of light through prism or refraction as such is basically pure geometry. Here also you need to calculate the angle step by step. First is in the upper angle, upper right angle triangle. You can see the 90 degree angle. The ray is making 90 degree with the perpendicular surface. From that you can calculate the angle between the ray and the hypotenuse surface as 30 degree. Is simple geometry angle calculation. So if that is 30 degree, that means the incident angle I is 60 degree, that is 90 minus 30 is 60 degree. If that is 60 degree, for internal reflection, the angle of reflection also here will be 60 degree. That means for the second refraction, the angle of incidence is 30 degree. You pure geometry, you draw the line, calculate the angle. So angle of incidence is 30 degree. If the angle of incidence is 30 degree in the denser medium, for refractive index √2, R will be 45 degree because refractive index is √2. Sin 30 degree by sin R, that will give you value of R as 45 degree. It's pure geometry. Next MCQ. For a 45 degree prism, the light ray entering perpendicularly at one refracting surface, and that meets the critical angle at the other refracting surface. You need to calculate the refractive index of the prism. 4 options given, 10 seconds time, timer starts now. Time's up, let's see the answer. Answer is 1.4. It's simple. You need to find out refractive index. That means you need to find out angle of incidence and angle of refraction. It is critical angle, angle of refraction, you know, 90 degree. Now we need to calculate the angle of incidence, that is critical angle. You look at the triangle, ray is entering at 90 degree. So the ray is making 45 degree with the other refracting surface where it is getting where it is creating critical angle. So value of critical angle is 45 degree. So you see you got the value of mu. 1 by sin 45 degree, that is √2, that is 1.414. So your option is option C. Next MCQ. For an equilateral transparent prism, light ray enters perpendicularly through one of the refracting surfaces. It moves out through other refracting surface. The outgoing ray is parallel to the third surface, that is base. Now which of the following options is correct? Refractive index of the prism is higher than the medium. Refractive index of the prism is lesser than the medium. Refractive index of the prism and medium, they are same. Refractive index of prism and medium cannot be compared from the given information. You have got 10 seconds time. Your timer starts now. Time's up. Let's see the answer. The answer is option B. That is, refractive index of prism is lesser than the medium. That means the refractive index of medium is higher. You draw the diagram, you can easily find out. Next MCQ. An equilateral hollow prism, that is air inside, is kept in oil. A light ray enters perpendicularly through one of the refracting surfaces and moves out through the other refracting surface. The outgoing ray is parallel to the third surface, similar to the previous MCQ. The outgoing ray is parallel to the third surface, that is base. You need to calculate the refractive index of oil. 4 options, 15 seconds time for you. Timer starts now. Time's up. Let's see the answer. Answer is option D, that is 1.73. And the diagram is drawn here. Let's see the calculation also. See, you have to calculate refractive index, so you need to find out the angle of incidence and angle of refraction. Easy. So angle of incidence is 60 degree because ray is entering perpendicularly through the first refracting surface. So on the second refracting surface, the angle of incidence is 60 degree. And the outgoing ray is parallel to the base. Draw the line, calculate the angle. That angle will be 30 degree. So you have got both the angles. So refractive index will be sin A by sin R. Simple. Pure geometry. Easy. The questions look difficult, but once you draw the diagram, try to find out what exactly is required is easy. Next MCQ. For an equilateral glass prism of refractive index √2 kept in air, what is the angle of incidence on the first refracting surface so that the ray just meets the critical angle on the second refracting surface? See, for this equilateral triangle, as we have seen in many MCQs, that if the ray is entering perpendicularly on the first refracting surface, then it is getting internally reflected. But here the question is, at what angle it will create critical angle on the second refracting surface. So the question is, for an equilateral triangle glass prism, the refractive index is √2, it is kept in air. What is the angle of incidence on the first refracting surface so that the ray just meets the critical angle on the second refracting surface? 4 options given. You may require some trigonometric values. So values are given here. You have got 20 seconds time now. Timer starts now. This is a super MCQ. If you can solve it, take your own time. If you can solve it, then you are a champion. Take your own time, do your own calculation. You will love it. Time's up. Let's see the answer. The answer is option B, that is 21.5 degree. Let's understand the calculation. Look at the diagram. What you need to find out? You need to find out the value of I. And what is given? That at point D, it is creating critical angle. So let's focus on point D first. So at point D, the critical angle value will be 45 degree because refractive index is √2. So you do sin A by sin R, mu is equal to 1 by sin C, you get the value of critical angle as 45 degree. That's easy. We have done many MCQs on this. So critical angle is 45 degree. We got this angle 45 degree. Now you look at the left picture again. Look at the quadrilateral A, B, C, D. Angle B and angle D, both of them are 90 degree. So angle A plus angle C will be 180 degree. We need to find out the value of angle C. So angle C will be 180 degree minus A, and A is 60 degree equilateral prism. So angle C is 120 degree. Now look at this triangle BCD. Now your objective is to find out the R, because you need to find out A. If you can get R, you know refractive index, then you can find out value of I. So in this triangle, we have already calculated D as 45 degree, C as 120 degree. So what will be the value of angle B, that is R? That will be 180 degree minus 120 degree minus 45 degree. That means 180 degree minus 165 degree. So that will be 15 degree. So you got the value of R as 15 degree. Not to worry, you have got the value of sin C given in the trigonometric table. So now we will do simple sin I by sin R. Sin R is sin 15 degree, value of that is given as 0.259. So you get sin I value as 0.259 into 1.414, that is 0.366. So we also have been given the value of sin I, value of I for which the sin I is 0.366, that is 21.5 degree. So that angle is 21.5 degree. That means if the angle of incidence is less than 21.5 degree, the ray will suffer total internal reflection, because at 21.5 degree it creates critical angle on the second refracting surface. Hope you like the video, hope you like the MCQs. Please subscribe to the channel. Do like, share and comment on the video and press the bell icon. Thank you for watching this video. We'll come up with many such videos. Bye bye till then.